Hello, welcome. Today let's try to solve another leetcode problem. 1524, number of subarrays with the odd sum. We are given an array with integers like 1, 3, and 5, and we want to return the number of subarrays with an odd sum. So the subarray is always be a continuous array. For example, 1, 3, 1, 3, 5, they are the subarrays. We want to find the odd sum. So inside there are like 6 subarrays and the odd sum, which is 1, 9, 3, and 5. So we're gonna return an answer of 4. But how should we solve such problem? If we use brute force, it will be O(n) squared because basically we can use a prefix sum to sum up the values. Let me use this example 1, 3, and 5. So let's try to use this example 1, 3, and 5. If we have 3 numbers, we're gonna use the prefix sum to check. So it's gonna be 1, 4, and 9. If we use the brute force, we're gonna check like 4 minus. We're gonna prepare a 0, and then we're gonna have other 3 numbers. So we're gonna use the 1 minus 0, 4 minus 0, 9 minus 0, and then 4 minus 1, 9 minus 1, and 9 minus 4. So we're gonna check all the possible results, and then we're gonna check which one is odd. So it's gonna be n squared, and it will not be possible because it will be time limit exceeded. Now we're gonna use some tricks to solve this problem. So basically, for me, I gonna use dynamic programming. Because, for example, for this number 9, we don't need to check one by one, like we're gonna check this number 1 or check this number 4. Basically, I don't need this number 0 even. I just need to check how many odd numbers before 9. So there's 1 odd number before 9. And how many even number before 9? It is still 1. So this is odd, and this is even. There's 1 even number and there's 1 odd number before 9. So for the next, we just need to check if this number 9 is odd. If this is odd, which means the odd number minus an even number, it must be an odd number. So how many even numbers? There's 1. So so there's 1 odd number. Yes, it is right. Yes, and for this 9, there's 1 odd number, and there's 1 even number before 9. So we're gonna use this 9 to check. So this 9 is an odd number, so the odd number minus an even number, it must be an odd number. So this would be 1. So for this number 9, we find 1 odd number, and the 9 itself is an odd number, so 1 plus 1, so it is 2. So for this number 9, we are sure there are 2 odd numbers. Maybe we're gonna check one by one, not from the end, from the beginning. So for the first number, let's try to check one by one. So for the first number 1, how many odd numbers and even numbers before 1? It is 0. Right. So how many odd numbers up to this 1? It is 1. Because the odd number minus even number, it must be odd number. But the even number is 0, so it's gonna be a 1 directly. And for this 4, we also need to check how many odd numbers and how many even numbers before this 4. So there's 1 odd number before 4 and 0 even number before this 4. So 4 minus odd number, it must be an odd number. So we find another odd number. So 1 should plus 1. So we find 2 odd numbers. Because this 4 minus 0, it is even number, so we don't need to count. And for this 9, I've counted before, there are 2 odd numbers. So 1 plus 1 plus 2, the result is 4. Because we just need to record how many odd numbers, how many odd sums in total. So it is before. As you can see, we can solve it by using the dynamic programming. So for each number, we just need to know how many even numbers before it and how many odd numbers before it, because we can use mathematics to calculate. Yeah, this number itself, if it is odd, we're gonna plus a 1. So if there are even numbers before this odd number, so we're gonna plus the even number. Yeah. So for example, if this odd number is not 9, it is 8. It is even number. So we're gonna use this even number to check how many odd numbers before it. If it is 1, so we're gonna plus the odd number. Yeah, we're gonna plus 1. And we don't need to plus itself because the 8 is not an odd number, it is even number. Yeah. Let's go back to the coding. Maybe you will see it much easier while coding it. So we're gonna have a record of odd and even. So from the beginning it is 0 and 0. So this means how many numbers, how many even or odd numbers, how many odd even before the current number. Yeah. Now we're gonna start the dynamic programming part. So we're gonna do some pre-processing of the array. I'm gonna use a list accumulate. So this is basically the prefix sum of the array. Now I need to prepare a result and modular. So the result would be starting from 0, and the modular is given by 10 to the power of 9 plus 7. Now we're gonna check one by one for the nums inside the array. So we're gonna check this number n. If n modular 2, if this is an odd number, so the result would plus how many even numbers before it. But this is also an odd number itself, we need to plus a 1. Now we need to update the odd number, so the odd need to plus 1. After it, else result would plus the number of odd, but we don't need to plus 1 because it is an even number. We don't need to plus itself. So the even number would also plus equal to 1. As you can see, it's a dynamic programming. And it should be much easier when you understand how we're gonna solve it. Now let me run it to check. As you can see, it works. Now let me submit it. And the time complexity is O(n) because we just needed to check how many numbers inside the array. And this is also a prefix sum. This is also O(n). Because I didn't modular the mod. This is why it is wrong. Now let me submit it again to check. As you can see, it works and it's pretty fast. Thank you for watching. See you next time.